So my name is Craig, and just want to thank you for all giving me the time this morning to sort of deal with this pretty exciting topic. There's quite a bit I need to get through today, and so let's get started right away because I've got stuff to demonstrate to you and some software to work you through, all of that sort of stuff. So just a very, very quick blurb, because obviously I want to make sure you know who we are, but we're a strategic design firm that sort of really just focuses on these three dimensions. A lot of what I'm going to be talking to you today about kind of sits between 1 and 2. So the why might we and the where might we play and where might we win aspects. How do we experiment with strategy? How do we experiment with policy? And how do we experiment with that into a business structure? And that's what we're going to be dealing with today. Now, there's a few PowerPoint slides that I'll start with, but I want to make sure that I whet your appetite for what's coming. And so today we're eventually going to land on a system dynamics model that looks like this. And so, I'll be working you through what you see on your screen, what's happening, what's the behavior. So we'll eventually land up here, and hopefully I'll be able to build you up to that. And so that was just a little piece to whet your appetite. We'll come back to this model as we elaborate a little further. But really just to elaborate a little on what is a digital twin. And I think at the moment there's a little bit of confusion. And the point of what makes a digital twin is that it's almost feed forward and feedback components are in place. And so it's a representation of your physical environment in which we can collect the data, we can extract some sense from it, make some decisions, and then intervene in that data back into the system. And it's slightly different from traditional models. So you can see the journey that we've taken here. You've got a digital model, which is what a lot of people are used to, how we model stuff in modeling software. You're going to see a little bit of that today. And then it kind of moves to a digital shadow in which you're actually able to take the live environment and connect that into your digital object, and then moves all the way across to a digital twin in which you've got the feed forward and the feedback components working effectively. So when we talk digital twin, we want to head in that direction. We're going to sort of be sitting a little bit between the three of these today as we talk about a broader perspective of digital twins. Now, I also just to say, by the way, I've got Marius on board. If you do have any questions or comments, drop them in the chat session and we'll hopefully be able to deal with them at the end of the session. So there's normally about 4 types of digital twins, and really it's all about decomposition and to what extent we can create digital footprints of physical environments, whether it's small parts or component parts, whether it's assembly of those parts into bigger units, or whether it's the process or the system that runs around it. Those tend to be the dominant definitions of the form that digital twins can take. And some of the challenges within this space, really, and I was on a call yesterday, the UK has got a digital twin hub, and we were sort of brainstorming around how can we grow the interoperability of digital twins across the globe so they can start to share more information. A lot of the talk around digital twins is very much in the built space. So infrastructure, environments, physical type of environments. And so there is a slight problem with that because they're borrowing a lot of that. So a lot of conversations tend to sit within that area, not necessarily the broader system view. Second problem is that they deal with what's called complicated. So you have this complicated area in which we know what the problem is, we know what the solution is, and it fits into what's referred to as the known knowns. Whereas it doesn't necessarily go up into the complexity space. So what about sort of social interactions and citizen behavior and all of the dynamics that play out within that aspect? How do we capture those details and be able to mirror what we think is happening within industry and the environment? So a bit of a limitation there. It also tends to deal with what we call concrete. And the concrete space is, as we said, it's physical. But, when we talk about digital twins, it doesn't necessarily deal with some of the abstract components. Well, what about a policy? Can we even create a digital twin for a policy? What about a strategy? Can we create a digital twin of a strategy so you can actually play with it and see how it impacts your business? And that's my hypothesis that I'm going to be discussing today. Now, what's interesting coming out of the digital twin conversation yesterday was we were talking about the Gemini papers. And this is a series of papers that the UK, the Digital Hub, has published around standards for sharing information and interoperability with digital twins. And what's interesting here is if you have a look at the underlying pieces, there is a struggle to manage the whole and all of the pieces and how they fit together. And the complexity of systems, or a system of systems approach. So whether it's social, whether it's infrastructure, whether it's economic, they're all systems, and how do all of them interoperate together. And so there's a strong view to follow a systems-based approach to address some of the complexity around that traditionally built environment digital twins. And so my hypothesis is that there's a piece that's missing. If we consider the digital twins, you've got other aspects around the infrastructure. We call it the dark matter. So what's the structure and the relationships and the behavior that sits behind this? And that's where we're going to focus some time today. I specifically want to talk around, well, how do we model that dark matter, that underlying structure, and can we get it to a state where we can actually experiment with it and interact with it in a way that represents the business and facilitates decision making. And in order to do that, I'm going to take you on a little bit of a journey, just as we deal with a combination of some disciplines. And so what you see on the left-hand side here is Roger Martin's knowledge funnel, which become fairly well known in the industry, the broader architecture industry, let's say. And what you have is you've got this concept of a mystery at the top, and wicked problems, all those things set up there. That's the complex area. And through a process of design or systems thinking, we try and understand that mystery better so we can at least understand some of the rules or heuristics, the rules of thumb. Important to remember that word. All right. And eventually we want to get it down into an algorithm space. And so the diagram on the right talks about different ways that we've applied systems thinking into these areas. So up in that between the mystery and the heuristic tends to be quite abstract. And so you would tend to follow more of a design-based approach to understand how we can unpack that system, the causes and effects, looking for the leverage points, all of those different tools that can be used. But as you sort of move further down into the systems thinking discipline, there is what's referred to as system dynamics, which is a quantitative technique to model the behavior of a system, connect it to a live environment to inform decision making. And those are the pieces which we'll elaborate a little on today. Just quickly on the top bit, the systems-oriented design. It's probably a little small for you, but you'll probably get the idea. So this is our systems-oriented design toolkit. We've developed it for some large organizations around the world that license it from us. But basically, it helps us deal with that complex space. And how do we, looking at this top area of design thinking and system thinking, how do we move this down into becoming getting a little more clarity around the behavior of the system? Now, what I want to draw your attention to is you can see here, there's a system dynamics reference model that's inserted in here. And then down the bottom here, there's a system dynamics scenario and simulation model. And so those are the pieces that we want to actually refer to. So you can see up at a systems-oriented design level, we can come in at the intersection of systems thinking and design thinking, and that's where we do systems-oriented design. And some of the models you're going to see today, we use within that space. Secondly, if we look a little further down the stack, perhaps at the intersection here of systems thinking and the architecture thinking discipline, we have something that looks like this. So this is, well, how do we design the business? And what I've done is I've inserted in the system dynamics and scenario planning mechanisms down here. So normally when you design a business and you're a business architect, there's a bunch of tools and frameworks and artifacts that you're going to create. And on your screen now, you have an example of a few of those. The problem with a lot of those things is they're quite static. And so if we've got a value stream or we've got a capability model, how can we make it live? How can we give it some behavior and get it to actually behave and deliver some of the outcomes? And how can we see it interacting with other capabilities across the business and processes and resources? And so what you have is you've got a means to take these static models and build them in a dynamic environment where you can now start to witness their behavior. And it's a bit of a chicken and egg situation. What we like to do is first build a system dynamics model so we can understand policy, strategy, all of those pieces. And then off the back of that, we can now start to extract structure, function, and form, value streams, processes, all of those aspects we can actually pull out. So that's slightly more top-down. A bottom-up approach would be, well, we could do the traditional architecture of business architecture thing, value streams, capabilities, processes, operating model aspects, and we can then feed that back into our system dynamics model and start to replicate that behavior. So you've got two avenues to pursue it by. I'm not downplaying the need to work through the traditional business architecture artifacts to understand the business more. What I'm proposing here is let's give those artifacts some life, and not just life in a silo, but life in a system context. Because normally what happens is what we've got is these models tend to be quite static. And so at the top, you've got an ecosystem model. On the right, you've got business models interacting with other business models. Further down, you've got value streams connecting down into operating model concepts at the bottom. And the challenge we have is that these are quite static. Now, you can take some of these static models and begin to automate them. And we do that as well. Let's just quickly have a look at one of those models so you can actually see one of those running. I believe it's in here. Let's just log in again. So this is a tool called Adonis that we use. And what we use with this one is we model operating models in this tool so we can have an understanding of all the operating model components. Now remember, this isn't a tool demonstration, but I'm going to use Stella as well as some other tools just to show you how we can replicate some of that behavior. So normally you might have an understanding of, I'm just going to try and move into one of these. So you can sort of see in this area where all your components might sit around operating model design. And so we want to understand SIPOC, organizational, RACI, all of the content that we need still needs to go somewhere, but at the moment it's still quite static. Well, can we actually take this and do something, perhaps a little more dynamic in nature? And so in this particular case, you can simulate processes. And so I can actually simulate the process over a year, number of transactions. Let's actually execute the process and see how it works. So this is down at operating model level and not entirely static, but also not really a digital twin, is it? It's really just running on top of a model. We're not necessarily, and you can connect into process mining activities and feed that forward. There's a few other ways that you can begin to automate this. But through tools like this, we can start to see, all right, how does the process execute? What's the overview? What's the capacity of my staff as they're executing? How long does it take? What certain events and paths can we travel as we move through this environment? So good tools to analyze process and for us to begin to simulate, right up top level value streams, and also we can do that right down at the bottom. And so I've called those partially static. But what we actually want to do is we want to get into the slightly more, or more significantly more dynamic nature of how do we take this environment and instead of having one model here, one process here, one value stream here, what happens if we put them all together and create an environment that we can see the behavior of how they all operate together? And so what we want to be able to do is build the dynamics of this into an environment. And that's where we called it a system dynamics digital twin, because we want to see the behavior of all of the components. The thing that only makes this vehicle successful is when we understand all of those pieces, their behavior with each other, and we can then begin to simulate it and run some experiments on it. All right, so that's enough of the PowerPoint space. Let's go and play a little and introduce you. How am I doing for time? Cool, I'm on time. Welcome everyone. Apologies once again for the LinkedIn streaming problems that we had. For some reason, there was no button which allowed us to switch the host off and go live. We'll sort that out for next time. I think it's some issue between Zoom and LinkedIn, which is giving us some headaches. All right, so this is a tool called Stellar, and it is a system dynamics modeling tool. So you've heard of things like causal loop diagrams, system dynamics models. The focus is mainly here. How do we quantitatively design a system and the behavior of that system in this environment? And so I'm not going to do a tool introduction session. There's a few pieces which we'll talk about, but really what we want to do here is let's take a value stream that's very traditional market self-serve, right? And so how do we understand the behavior of market self-serve? So you remember in the beginning, for those of you that weren't here, this was the example that I had running where we want to be able to get to. And so I want to begin to understand, here there's a pipeline that sits across the top here, and there's certain behavior. What's the right mix of moving opportunities through a pipeline and servicing those? And do I have enough staff? What is my resource associated to it? This is the example that I'm choosing today to talk through, because I think it's got some strong synergies with the business architecture element. Now, remember, a lot of the stuff that we do at this level as well is quite environmental and sustainability involved as well. So there's a link, a couple of blogs on our website where you can look at things like competing objectives. I did talk there around balancing the fish supply with the economic return of a fishing village. And so there's those broader ecosystem type of examples.
So it normally just takes a second or two, and then Craig is back. Craig, you just paused there for a few seconds, so okay. Just maybe iterate one or two things. Thanks, Craig.
Right, I'm back. Thanks. I did ask Morris. I said, for some reason, my internet has a 20-second dip. So anyway, thanks, Morris. All right, so what we want to do now is begin to mimic some of the behavior across that value stream. And so what you normally want to do is start with some form of hypothesis, or what behavior do you want to see occur? So what I've done is I've created what's called a reference mode. And I've said, all right, well, this is the behavior that I want to see over time. And I've set this to 24 months. I'd like to see my customers increase in this nice little curve. All right, wouldn't we all like to see that? And so that's a target approach. And you can see if I drag this here, the graphic that I'm going to put in here. And what this allows us to do is just to see this in real time. So I'm going to put that there, and then I'm also going to put the actual customers here. And so what this allows me to do is effectively run this environment to start to see, all right, well, how many customers can we add into this space? So we have to design a model that must reach this target. And so this is what we're doing is, all right, we work with things called stocks and flows. And so what it's saying is try and imagine this customer is like a bathtub, and over time we fill it up with water. And there's a valve, a flow that comes in, all right? And on that flow, there is a tap. All right, let's just do that. And there's a rate at which customers come into that, depending upon how you turn the tap. And there's a bunch of variables that you use in order to influence that, all of which have got formulas associated to it. That's really the basics of it, stock and flow. And so depending upon the rates at which you adjust your taps and your flows, the stock will either improve or decrease. And so important to remember that I can put anything in the stock. It can be goodwill. It can be ambition. It could be skills. Some of those things that are they're more qualitative than quantitative, but I have to come up with a qualitative index to associate it. So I can model even a systems blueprint on here and how we can shift the behavior of personas from one persona to the next and see patterns of behavior. All of that you can actually build into these stock and flow diagrams. We won't go into that detail too much today. All right, so what I want to do, I want to just try and build you up a little so that you can start to understand some of the basics and start to see, well, how does it actually work when we get to the end? All right, and so what we do is we add a flow in here, all right, and then I've got a churn rate here. So I've said 2% of my customers are churning. At the moment, I'm adding, so many through sales. And so I'm going to just drag a variable in here. I'm going to do this for now. And what we can do is I can, effectively connected in there. And I can start this with, well, how many do we want to sell per month? So let's make this 500. All right. And so what this allows us to do is, let's just run this model. And you can see I can drag this back. All right. And I can start to see, well, what happened over time. And not only that, I can actually begin to adjust these figures and say, well, how much do I want to sell per month? So this allows me to now interact directly with the model. So that's one small piece of my value stream. All right. And I'm beginning to model and understand behavior. And so this is what we want to do. Is we want to start to build out all the structure so we can get to a point. So I want to get to a point where my customers can be in line with my target. All right. So let's maybe reduce the churn. So we can experiment a bit with that. I don't want to make it 0, but let's make it 1%, 2%. Okay, so I can sort of get a similar curve if I manage to reduce my churn, and there I've increased my sales to 513 customers. All right, so now what this means is I can start to work from this, and I can work backwards. And I can actually get to a point where I can see the actual interventions that I need to execute against my value stream. And so, what we can have is, I'm just going to delete these pieces here and add the rest of my value stream in. Oops, let's do this. Yeah, and here I've addressed the rest of it, because normally what would happen is you'd start to work back from customers, and you'd say, well, where do I get my customers from? And then you'll identify your prospects. And then off the back of your prospects, you'll say, well, where do I get my prospects from? And so over time, what you're doing is you're actually getting to the point where you're thinking through the process of how you're getting customers, and it's your value stream. All right, you can call it a process. We don't really worry too much about those terms in this world. Hopefully, you can still hear me. Okay. And so what I've now done is I've said, all right, I've got some flows, and I've got a total addressable market over here, which I've set to, what's that, 100,000. And there's a portion of those that I convert through prospecting into leads. Then there's a portion of those that I qualify into my prospect base. And then there's a portion of those for customer acquisition that become customers. So you can see like multiple little bathtubs along the way that store value as you move through the cycle. And I've done a very, very simple thing here. I've just applied a couple of rates here. What's the conversion rate of suspects? What's the conversion rate on the lead conversion rate? And now you can get a slightly different outcome as we run this, and you can see, wow, look at that view there. We can actually get significantly more, and same story is I can tweak these, and I can get them to a point and say, well, I don't actually want that many customers. I don't know if that's possible. All right. But, let's say my churn rate's actually quite high. So if I'm on a 15% churn rate, all right, well, how many customers, how many suspects must I move through this? And so what you find is, as humans, we can only deal with 9 bits of information at one particular point in time. That's for the geniuses amongst us. Average is about 3. And so it becomes quite a challenge for you to figure out, well, which lever do I want to pull here? Do I want to pull the lead conversion lever? And what's the results that that's going to give me? Do I want to pull the customer acquisition lever? What's the results that that's going to give me? And so, you can imagine in a large system diagram, you're going to have thousands of these levers, so they can get fairly huge. And so your ability to figure out which of these to pull is severely limited. And so what do we do about this, and can we change it? All right, so let's move to the next model. And so what I've done here is I've altered it slightly, and I've said, all right, same principle, but let's talk about capabilities. So, the architecture community loves the capabilities, and so can we in some way link capabilities to this? So could I take the marketing capability here? Yes, maybe there's a lead qualification one down the bottom here. And could we give it a general maturity score out of 10? All right, and so I've set this to 10. All right, they're all currently set to 1. And the impact of this maturity on the conversion rate is what I'm interested in. So you can see I've built a graph, and I've said, all right, well, if we don't know exactly what's going to happen, it's not a binary sort of a relationship, can we build it in a way that at least shows the behavior? So obviously, naturally, as my marketing maturity improves, be it the people, the process, the technology, we can expect that my conversion rate is going to get better. All right. And so we want to be able to mimic some of that behavior. And so that's what we've done. over a maturity level of 0 to 10, we can affect it from 0 to 100%. And that's been done across all of these cycles here. You'll see as well that I've taken customer churn, and I said, well, if we churn some customers, they actually go back into this and they become future prospects for us to work with. So we still know them, we have their detail, we can cross-market to them. And you'll start to see, I'll start to build in formulas like this. Every one of the variables you see on the screen, they become things that I can reuse and calculate and work with throughout the entire system. And so now we have a situation where I can now run this model and I can start to see, all right, I've optimized this model already. If I'd broken it, the graph wouldn't look like that. But you can see here that according to an algorithm that I ran on this, now remember that in the previous session, we spoke about you manually trying to affect this. And so if I were to ask you to manually configure these pieces here, you'd start by moving this one and trying to figure out, well, what's the impact of that going to have on the graph? What's the impact that lead qualification is going to have? And you try and find the right balance. Very difficult activity to do, especially for lots of levers. And so what Stella does, for example, is I can set up what's called a payoff. And I can say, all right, I actually want to maximize my customers. And I want the final run to be maximum. And I want to optimize that. There's a maximized piece. And I want to optimize these levers. So now I can tell it, I've got a marketing maturity lever, lead qualification lever. What's the best maturity that I want out of those capabilities in order to increase my number of customers? So I don't have to do all the hard work here. So I can basically set those parameters and I can go and run this. And this comes back with a whole bunch of data and it talks about the payoff here. And this has come up with a configuration which looks like that. All right. Because of its non-deterministic nature, I'm seeing unstable internet messages come up here. I'm hoping I'm still okay. So what the algorithm has done is come up with some options. You can see here, it runs through a variety of different simulations to be able to work with. And according to this, I can actually get that maximum detail. Obviously, there's huge dependencies in your entire system. We're just looking at a very, very one value stream across one business. And, if business was this simple, that'd be great, right? But what we've got here is you can see that, oh, I need to set these to 10. All right. Well, what happens if I can't, my service maturity, I don't have capability in that space? Well, what happens if, the maximum I can go for, service maturity is I can only get that, costing me too much to maintain that call center. I can only get that to a maximum of 4. All right. So, what's going to happen in that particular scenario? How close might we actually get to it? So are there other levers that I can use? And now you can start to see slightly different behavior occurs if I don't invest sufficient into that particular capability within my business. And so now I can now experiment. I've got a very, very basic value stream model here that I can now begin to experiment with and find the balance in the system, those types of things. And obviously you want to work as you mentally think through creating these models and designing your business. The mental patterns, the heuristics that I spoke about in those initial slides are the pieces that you capture, and then you can actually put them in here. And you build them in so that you don't have to make those decisions in the future. So it's not as though I have to think around the best balance between these levers. I can use the simulation to do it, but now I can start to understand the rules around, okay, are there some rules around the balance between these entities? What about aspects like this? What happens, all right, if I've only got so many resources in the business and I can't allocate the 5 staff that I've got to those areas? What's the impact of staff on the maturity level of a capability? So we could say, well, number of marketing resources required to improve maturity by 1. All right. So there's certain rules that we can create like that, which say, well, it takes one person, working over 1 month to increase that maturity by 1, and it takes that person leaving that job another month to reduce that maturity. That's the type of behavior that we can start to capture into the system and start to mimic some of that behavior that's occurring. So that's what I have ultimately got to this level. Okay. And so I thought, I'm not going to rebuild it in that model. I'm just going to come back here and reuse this one. So same story here. It's slightly reversed. It's coming right to left, and I've altered the terms a little. For some of you that have service business, you'll understand those terms. But you can see there's a bunch of different dynamics that are now playing out. And over time, this model gets built out more and more and more as we start to understand. All right, so we've got identified, we've got proposed, we've got won, we've got delivering. And so in the perfect world, we can get that value stream. We get heaps of revenue from all the projects we deliver. However, in a service-based business, we're dependent on people. And so we need to now take the balance of people assigned to the project, all right, and who's not assigned. And when we start to run out of people, how are we going to recruit them and bring them back in at particular points in time? And so you can see that I now have got another dependency, not only on the pipeline, but I've also got a dependency upon skilled resources that actually sit within this place. And this is a very simple model looking at skilled resources. You can actually grow this, that as you recruit from the assigned pool into not assigned, they come in as beginners and they go through a cycle of intermediate to advanced. And depending upon the project, you need 5 advanced people and 10 juniors, whatever the case might be. You can actually build that behavior in as well. And so now what we can do is the same story here. It's based upon the rules that are sitting in here. We can actually now see, well, how does this behave? How many leads do we need to have on the side, sort of coming out into the end? And what's the total number of projects that we can have? So you can see I've set a few variables here. So for example, there's an engagement margin of 55%. We want to be able to stick to that. We want to look at what's the average head count per project. So yeah, it's 5 people. All right, so every one of these big green dials are inputs that I've suggested we might be able to tweak. All right, same story here. How long, what's the time to deliver? All right, and what's the time to close a deal? What's the time to qualify a deal? What's the success rate? All of these aspects are what we would build into the business architecture of that value stream. But we want to see the behavior across an entire system. Right. And you can see this one's taken right up into an income statement, all that sort of stuff going right into shareholders' dividends declared, and you can carry them further. We've got modules here as well. So modules, for example, are little agents that sit separate on the model that we do calls to. So as your model gets bigger and bigger, you can break it up into these modules. And so you don't necessarily have this massive clustered model. And these things get to thousands of variables, by the way. And so now I've got a little bit of behavior that I can mimic, and I can do that. I can follow the same story here. I can say, well, hold on, let's run some payoff scenarios here. And I want to increase profit. And what are the levers that I can pull? Time to deliver, time to close. So I've got a few levers that maximize my profit. Let's run this model and sort of see where we land. All right, so this not dominant solution means that the weighting and the algorithm I used, there wasn't a dominant result which came up, which means there's some variance in there that I need to cater for. I'd either use a different algorithm, but let's work with it, okay? And so in this particular case, this is sort of said, well, if your reference target profit, which is this one, that's the profit that you wanted, all right? But if you configure your dials in the following way, then we reckon that we can get this green line of profit occurring over here, all right? And so now I can look at this and I can say, well, how can I reduce this hit in the beginning? So I've got this $100,000 hit of cash flow, working capital. And so I need to figure out the best way to intervene with that. Could it be that I could change the number of starting projects so that I don't have that cash flow hit? Right? That's one way to do it. So if I were to drop this and say there's one starting project, you can see I've been able to flatline that. So I've been able to manage my cash flow a little more successfully. So in trying to mimic that behavior, I'm now able to play with it and then build the rules in. So I thought, well, let's not do that manually. Let me rather do that in an automated fashion, right? And so, yes, let's pop this back up to 2, but, this one looks at the cost of bringing on an employee. How many months of working capital do you want in your back pocket before you start to hire those staff? So don't kick off any new projects. Don't take one deals and deliver them until you've got trained staff on board, and it takes 3 months to bring them on board. So you can see here is, all right, well, what happens if I only require 1 or 2 months of working capital? In other words, I don't have much liquidity to bring on new staff. And I can start to see, well, what's the impact that would occur for these staff. And I can sort of see, well, hold on, seems the 1.27 million profit's pretty good. So having a 4-month window, having 4 months of capital before I start bringing on people is actually too long. I start to lose revenue. So it looks like 3 months here is probably my sweet spot to be able to work with. What happens if I want to start with more projects? Is there something else that we can actually work with here? So here I can start to now play with these dials, and I can also start to affect some of these aspects. And what's interesting on the way this algorithm ran is that you can have the best sales capability and closing of deals on this side, but the one thing that has the most impact on your profitability is duration of project, time to deliver. So if we were to bring this all the way down, okay, down to very, very short projects that only take 3 months or so, you can see the hit on the profit, right? So in mimicking the behavior of this environment, I'm now able to see, well, which is the lever that's actually going to have the most impact. And it's really about chasing bigger projects. So hopefully you can sort of see, this is just a little bit of a picture around how we can start to mimic some of this behavior. And that's why I said, look, system dynamics is a great way for you to create a digital twin of the dynamics of this environment, because it deals with some of that abstract layers at the top. And, whether it's a process, whether it's a human skill, whether it's, something mental related, emotionally related, all of those things you can actually model and build into this environment using very, let's call them tangible things like processes and people and all the rest of it. But there's also some of the more abstract and qualitative aspects that you can build into this. And what it allows me to do is to take not only my recruitment value stream in this case, but also my sales pipeline one, and start to see what's the behavior of these two value streams as they work together and not in a static environment. Now, where can I intervene? If I am now through this entire process, realize that my time to deliver is actually my biggest profitability point, well, what does that tell me in a business? Where should I focus my investment and my capability in trying to improve this business? And once you fix this, and like most things, the theory of constraints, once you fix the constraint here, you just move the bottleneck somewhere else, and then you can run this model at a later stage. Now, I can, like a digital twin, connect this into live feeds. So I can connect this to my project management tool. And over here, I can basically bolt on some data inputs that I can work with, either in a batch run or in a live format, so that I can actually keep this model up to date. Now, the one difference here from this as a digital twin is that it doesn't actually write your decisions forward. Okay, so it's still sort of sitting in that planning space. A digital twin, once it finds the optimum mix, executes your decision down into the digital twin. Now, we've done that past in multi-agent environments, where we've built the automation into the actual agent that makes the decision and then executes it on a sensor, which makes the adjustments in live systems. It's all possible to do, all right? There's some complexity related to it, but we prefer to sort of stay up in this space where we get the live feeds into this sort of digital twin or digital shadow, and we can start to make some decisions up at this level, which we can then, because they're of their abstract nature, we can cascade down into the rest of the organization. Interesting data point. We originally pursued a route which said, could we, all right, what about this feedback loop at the bottom here? So if we're talking about, a lot of what we're doing is sitting up top here, all right, we're creating live feeds from the environment, and we're putting those into a system dynamics model, and we're seeing the behavior of what's occurring, all right? But ultimately, those things drive decisions like what projects to cancel, how to redirect efforts, redirect resources across the business, focus more on this capability because we notice that it's dropping, right? You could use process mining on the bottom one. So process mining is the short, I won't say the easier way, but the way to read your live environment log files and then convert data into structure. So what we're doing here is we're creating structure and we're creating data. Right, and so you could use process mining to come back in, but fascinating study has sort of revealed that executives don't like the level of metrics and quantitative data that we have yet. It shows too much detail around their performance and that sort of stuff. And so some interesting dynamics, which we could probably model here, that tend to play out within that environment. For another conversation, I might talk about how we can connect process mining into this. But remember now, what you can actually do is if you've got a system dynamics model that sits at the bottom here, through running those simulations we spoke about, and there's different algorithms. Now imagine you've got, I don't know, 400 or 500 levers. And we tell one of those simulation environments to play with the best lever configuration. And there's no perfect one, so there'll be many different scenarios, n to the power of n-1 type of story. And so what you can actually create through this process is tell it to run, you need a more powerful computer than mine, but if we were to run, 100,000 scenarios or whatever the case might be, all right, you can create what's called a synthetic data set. And that synthetic data set, you've seen the impact of different levers on different outcomes. We can actually now use that to train a machine learning algorithm. So you can build synthetic data, which you can then also use for some of the more AI-driven approaches within your organization. And so that's quite exciting because it means that we make it a lot stronger within that particular space. But the area that I'm more excited about is, well, how do we take this through reinforcement learning into like a multi-agent environment and get those agents to actually make changes in that environment? And so you can see with the dynamics that we've created here, you can create an environment, and that's the rule sets around how parts of your business all run together. And each of those you can convert to an agent where you can actually run them in the environment. Well, what does that mean, Craig? Let me show you quickly. So, this particular example is all about cows and the grazing of cows in a field, and to what extent will we run out of grazing pasture. And so what this tool allows you to do is a multi-agent environment, which turns the field into an environment and each cow into an autonomous agent, and it runs according to the rules that you set up. So you can actually now build a scenario that looks like this, all right? And I can run it depending upon the grass growth. I can run this model, and we can start to actually create very simple. Yes, it's not quite one of the more modern environments, but it's simulating. So what it's now doing is we can take that system dynamics model, and I was going to build one for the value stream, but I've just ran out of time. Right, but ultimately you can create levels of visualization here, so you can actually see customers moving through, or all that sort of stuff. And this particular one is applying the algorithms and the heuristics that we've created in that model, all right, into an environment that you can now begin to visualize. All right, so this is actually what's referred to as an agent-based model. So that's what it's doing, is it's effectively taking components and creating that each of those cows takes a subset of that model that we've created, drops it into its own agent, and then runs it within the constraints of the environment. All right, advanced levels sort of stuff, but I think you get the idea. All right, so there's some value around building the correct structure here, and you can move it into reinforcement learning. You can move it into those sort of multi-agent environments, and I think that's where the future is going. I think this concept of static models and static value streams and all this, but we still need to do that. We've still got to understand how those pieces fit together. But unless we can demonstrate the decisions and how we've designed a value stream, a process, or an operating model, and show it actually working to our executives, it kind of loses value pretty quickly. And what I'm suggesting is we can now take those things and show our executives and our clients, here is the actual models that we've designed running in your business. And Mr. and Mrs. Decision Maker, you can actually see it working within your environment, and let's have a conversation about what levers we can begin to pull, etc., etc. And that really is very powerful in conversations. When your decision makers actually see their business running, it becomes a much more productive conversation. Hey, what happens if we do this? Could we do? How does quality of delivery affect us? Like, well, let's build quality in here. Let's go and drop quality under the delivering section, and let's see the impact of quality of your staff, and does that affect your churn rate of people leaving your business? All of those are hypotheses of questions that you'd want to answer, and you can build it within this environment. All right, so hopefully that's giving you a little bit of a bird's eye view. We call this a system dynamics model, and you can run simulations on it. And so we're starting to use the term digital twin, because we see it as something that is capturing the behavior of some abstract concepts, strategies, policies, the rest of it, all right, and how they all interact together, and allowing me to experiment with my policy, experiment with my strategy, experiment with business change, so that I can actually make some informed decisions downstream. There was one other thing that we also do. I see I've got maybe 2 minutes. I just want to quickly show you, which is this one. So what we've also done is in business model innovation workshops, you've actually got a number of different business models. So we do speed dating on business models, by the way. And each of these business models has got certain behavior. And so, well, what does a business model, can I apply this business model to my environment? What does it actually look like? So you can actually now take these different business models, and you can also model them within our environment, right? So let's come here, and here is the multi-sided marketplace and the behavior of your multi-sided marketplace. I've dropped this model in here because ultimately the one that we've been working on, which is the total addressable market converting to customers, kind of fits in here in this space. So this multi-sided marketplace is a reference model that we can now pull in, an assembly, so to speak. So you can see there's other assemblies here, a whole bunch of different types of models. So we've created these business model views, and we can actually now start to run that and see, well, you know, how can we run a multi-sided marketplace? And what happens if we now take our value stream and we bolt it into this multi-sided marketplace? What's the behavior going to look like? Slightly more advanced, by the way, is we can look at the causal loop diagrams and begin to start to understand the causal loop archetypes around what behaviors are we seeing that create reinforcing loops and balancing loops, virtuous cycles, vicious cycles that might be occurring across the business. All that becomes part of your ability to analyze. And so obviously this requires a certain skill set. And so what we've done is, here's my pitch, by the way. There is on our link, Morris, I don't know if you can drop that link in. There's some options around if you want to continue this conversation. No commitment, just say, look, I'm interested in understanding more about how to build these types of digital twins. You know, just express your interest there, and we'll have a conversation around what that might look like. That's on this page here. You can copy that link as well, and that'll provide additional information for you. So hopefully that's given you, good, we've got about 8 minutes left. It's given you a perspective on how to make some of those static models more dynamic. I'm not by any stretch arrogant enough to think that this is a silver bullet that'll solve problems and that this is the only tool to use. There's actually some really, really interesting tools in the market that not only are operating at the system dynamics level, but also take you quite far down into doing this at a process level. You know, we've had that conversation a few times. You know, can we do this at a process level? I can't show you this full model, you know, but this one is a fairly advanced model around economics and collapse of an economic ecosystem, that sort of stuff. And so, you know, you can model each process, but I think it's too detailed. So what we do is we monitor the behavior of actual processes. So in other words, what happens to the behavior of the system when you've got complex process versus complicated, and you can sort of see that working into the environment. What happens if, you know, we've got capability called an investment management capability. What happens if we improve the technology maturity or the people maturity or the process maturity by a certain amount? How much do we need to invest in it in order to improve its maturity? What's the impact going to be on the funds that we've collected, et cetera, et cetera? So you can get quite detailed within that space, but I wouldn't necessarily take it down into the process level. There's other tools like Adonis that can simulate it at that level. But there are tools like Silico and AnyLogic in the market that are also aiming down into that particular space. So I think it's an exciting space that's going to continue to grow within this environment. All right, so hopefully that's given you a little bit of a taste. Once again, apologies for our rusty start on the LinkedIn stream. I think a few people would have dropped off, but nice to have you with us. And I've probably got about a few minutes for some questions. Any questions or comments that are in the chat session, Morris?
Hi, Craig. No, I've put a thing out there to ask for any questions. There has been a question whether the session has been recorded. Yes, the session is being recorded, so I think there's a few people who would like to have access to the link. So maybe that we can post the link,
yep,
and maybe in the chat, but also maybe on your website, and then people can get the link there as well.
Yes, I will pop it into the LinkedIn session there for everyone to see. I will also drop it here. There's a few videos here, by the way. This one is, I've recorded one on balancing competing objectives. This is the phishing scenario I spoke about. So I'll drop it in here as well for you to have a look at. There's a few other ones in there.
Then there's another question from Gerard Otto, who asked, should do the capability mapping and value stream mapping aligned with strategy, objective, and goals first before going to the emulations? Or I take it, should you do the capability mapping and value stream mapping first and aligned with the strategy, objective, and goals first before going into emulations?
And I think that's a really good question, because we're kind of back to this model here, which is, where do we start? Do we do the traditional business architecture things first? So we understand capabilities, strategies, goals. We map and model that, so we've at least captured it. Then we take that and we build it into the system dynamics model. And we can then see how it behaves. That's one way to do it. I've got no problem with that way. I prefer more the other way. I found that once you play with the system dynamics model, so you kind of leave those things aside and you build the system dynamics model from what you understand from the policy document or from your interaction with stakeholders. And then you use that to identify value streams and capabilities, so slightly more top down. So the way that would look, I would come in here and yes, I've got the behavior monitored, but now I know where my leverage points are. And so I need to figure out, what are the capabilities that I need to increase my time to deliver, so increase my duration of projects. And so is there some form of methodology that we create? Are there some new products that we must innovate around that we can actually create more sustainable income over time? Must we diversify into more annuity-based service type environment? Could we change our business model so that we do value-based intention selling of services? So those conversations can now occur, and depending upon how we experiment with that conversation, could result in some changes downstream in capabilities, value streams, and goals and objectives. So it can actually sort of cycle around. But I think to be more realistic around that, if you're coming in as a business architect, you'll probably find that you can come in with those goals, objectives, value streams, and capabilities, then go through, and once we've captured and we have a vague understanding of the behavior of the environment, we now build a system dynamics model and we communicate and play that back to business. That's just as powerful. And so I've got a preference, which is the former, but this other way can work as well. All right.
Right, and then there's another comment just also from Gerard Otto, ask how does this align with the BizBock disciplines, as BizBock doesn't cover digital twins? And Matthew de George also made a comment that it's a great session. I'd like to see a bit more about this.
Okay. Thanks, Matthew. If you're interested in a bit more, give me your contact details in the chat session on LinkedIn or on the link to the website. Morris, did you post it here? There it is. Okay. And at least I can cycle back and have a bit of a community to talk around next steps. Look, I think it's perfectly aligned to BizBock. And so remember, what you've got in BizBock is you've got the means to standardize how you capture your business architecture. But the thinking pattern around how you get to those outputs is kind of, the BizBock guide won't actually tell you much about how to do that. And so I think doing this in a system dynamics model is very complementary to that. And you can then standardize it in the way the capabilities are described, in a number of the views that the BizBock creates, in the way that they describe value streams, in the way that they model ecosystems and resources, those types of things. Remember that BizBock, I think, is a bit weak on operating model design. I think they've created a separation between that. Whereas in a system dynamics model, I can model all of those aspects, skills of resources. I can model material that's available. I can model my network and relationships that I have with my partner network, and different things, and then processes and the people and all of those pieces. I can actually put that in its behavior here, which can also drive what is referred to as operating model conversations. And that's where I think BizBock is a little light in response to your question. All right, team, we're 9 o'clock, and thank you all for attending. It's been great spending the time with you. Hook up with me on LinkedIn, follow up a few conversations, but it's an exciting space. Lots going to happen in this area, especially from our side, and I think it's going to be growing, especially coming off the back of the digital twin conversation that we had yesterday with the UK Innovation Department, and how this space is growing. So it's definitely an area that I think you can upskill into. Have a good day, and we'll interact with you soon. Thanks, everyone.